Solving two-step equations. Okay, we have a few vocabulary words here we need to define. The first vocabulary will be inverse operations. Inverse operations are pairs of operations that undo each other or their opposite operations. Okay, so we're going to write that down. Pairs of operations that undo each other or opposite operations. Okay, and for an example, we're going to write down add. Opposite of that would be subtract. And then we have multiply. Opposite of that would be to divide. Okay. Solution. Solution is the answer to an equation. The answer to an equation. Okay, and for an example, I'll give you an example equation. 2x plus 3 equals 7. Our solution would be 7. Okay. Variable is a letter used in an equation that has a numerical value. A letter used in an equation that has a numerical value. Okay, we're going to write down the same equation, 2x plus 3 equals 7, and we're going to circle our variable, which would be the x. We don't know the value of that x, but we do know that it has a numerical value. Okay, the coefficient. The coefficient is the number that is multiplied by the variable in an algebraic expression. Okay, so I'm going to write down 2x. My coefficient would be that number that is right in front of the variable, which here would be 2. Okay, and our last vocabulary word would be constant. Okay, we know when something is constant, it does not change. So here, a value that does not change is the number not with the variable. Okay, so a value that does not change, and in parentheses I'm going to put the number not with the variable. The number not with the variable. Okay, and I'm going to write that same equation down. 2x plus 3 equals 7. So our constants here would be 3 and 7. Okay. So there you have your vocabulary words. If you want to take a moment here and pause the video so you can get a better look at those vocabulary words, that would be fine. Okay. All right. Over on the inside here, we have steps to solve two-step equations. Okay, our first step is we're going to use those inverse operations. And we know those inverse operations are opposite of add and subtract. When we see addition, we know we're going to have to use inverse operation will be subtraction. If we see multiplication, the inverse will be dividing. Okay. Our second step is to always start with the constant. Okay. Always start with the constant. And that's the variable that's not with the variable. That's the number that's not with the variable, excuse me. Okay. Third step is then get rid of the coefficient. That's the number by the variable. So we're going to get rid of the coefficient. And we do that by inverse operations as well. And remember to do the same thing on both sides of the equal sign. Okay, so this is a big thing here. Do the same on both sides of the equal sign, because just like with having a scale, it has a balance. Okay, so let's try one here together. Now, when we were doing the one-step equations, I told you to always find your equal sign, and I call it part the river. Okay, so we're going to part our river here. Okay, so whatever we do on this side of the river, we do on this side of the river. Okay. Now, my first step told me that I need to use inverse operations to isolate the variable, and I always start with the constant. Okay, so my constant here would be the 8. So I need to isolate this n so we can solve for n. So I need to move this 8 to the other side. In order to do that, I'm going to have to subtract 8 on both sides. Remember, whatever I do on one side, I do to the other. Okay, those 8s are going to cancel out, and I'm going to be left with this 3n. I'm going to bring that down. Okay, 20 minus 8 will give me 12. So now I'm stuck with a familiar equation. This is a one-step equation. 3n equals 12. Okay, and the reason why we call this two-step is we have to do two operations. Okay, so this here, 3n, that's multiplication. So the inverse of multiplication is to divide. So we're going to divide both sides by 3. That cancels out here. We're left with n here. 12 divided by 3 will give me 4. So now I'm going to check. So I'm going to plug this 4 back in where n is and see if it equals on both sides. So 3 times 4 plus 8 equals 20. So 3 times 4 is 12 plus 8 will give me 20. So that checks out. So my answer is correct. N is equal to 4. Okay. Now, modeling and solving two-step equations. Here we're going to use algebra tiles to model and solve 4x plus 7 equals 23. The first thing I'm going to do is make myself a key. Okay, x's is going to be equal to x. Okay, I'm going to use a red circle for my positive. And I'm going to use a black circle for my negative. So I'm going to model this first. So I need 4 x's. Okay. I need 7 positives. So I'm going to grab my red pen. I'm going to put 7 positive. 1, 2, 3, 4, 5, 6, 7. Equals. And I need 23 positives on this side of the equal sign because it says 23. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay, so I just modeled 4x plus 7 equals 23. So now, I'm going to do the same process I used when I solved it up here algebraically. I'm just going to use my algebra tiles and my little circles here. Okay, which we would have the black and the red chips. So the first thing I need to do is move my constants. So I need to move these circles over here on this side. So what I'm going to do is I'm going to take these, I'm going to circle them. I'm going to draw arrows, meaning I'm going to move them over here. Now, when I move them over here, I need to subtract them. So when I move it over here now, they now become negatives. Okay, so they're no longer over here. They're now over here, and I'm going to grab my black pen and draw me 7. 4, 5, 6, 7. So now I have to do what we call zero pair, which means to cross out positive and negative. Positive and negative, I don't have any more left. Okay, so positive, negative, positive, negative, positive, negative, positive, negative, positive, negative, positive, negative, positive, negative. Make sure I count it off 7. 1, 2, 3, 4, 5, 6, 7. Okay, so now I'm left with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So now I'm left with 4x equals 16. So now I need to divide these 16 equally among these 4 x's. So we know that each x would get 4. So I'm just going to one, 2, 3, 4, and 1, 2, 3, 4. Okay, so I just solved it. 1x will get 4. So x would equal to 4. Okay, so now I'm going to do this same problem, but now I'm going to solve it algebraically. Okay, I'm going to take this same problem. I'm going to write it down here. Okay, now this is the part I want you to do. I want you to solve this algebraically for me. Okay, now let's move to the next example, which is representing solutions on a number line. So here, we're going to have to do 2 things. We need to figure out how to write our equation. And once we get our answer to our equation, after we solve it, we're going to graph it on this number line. Okay, so let's read our question. And yank out that important information so that we can have an equation to work with. Ahmed is buying tickets to a museum. He buys one adult ticket that costs $7 and several children's tickets that cost $3 each. Ahmed pays $70 for all the tickets. How many children's tickets did Ahmed buy? Graph the answer on the number line. Okay, so some important information here that we're going to underline is one adult ticket that costs $7. Okay, now he has several children's tickets that cost $3 each. Okay, and we know that he pays $70 for all the tickets. So that right there is letting me know that all this is going to be equal to 70. So I'm going to put that on that side of the equal sign. Okay, so he has children's tickets that cost $3 each. We want to know how many children's tickets did he buy. So that's my value that I'm looking for. But I do know that each children's ticket is $3 each. So that's going to be 3x, and then he buys an adult ticket. So that's adding to it. So plus 7. Now what I want you to do is solve this. And once you get your solution, graph it on the number line. Okay. The last section here is determining if a given value makes the equation true. Okay, so in this example here, we're going to be given an equation and we're going to be given 3 different values for P. We're going to see which one of these values will make this equation true when we plug in that P. So we have Gabrielle made punch for a party. Her guests drank half of the punch. And then Gabrielle spilled 20 cups of punch. At the end of the party, Gabrielle had 10 cups of punch remaining. Okay, so here's my equation. It gives me my equation here. 1/2 P minus 20 equals 10. Can be used to find P, the initial number of cups of punch. We're going to determine which, if any, of the given original volumes make the equation true. Okay, now we can do this one or two ways. I'm going to first write down my equation here. So 1/2 P minus 20 equals 10. So my first value to plug in is 40. So if I plug in 40 here, It's going to give me 1/2 times 40 minus 20 equals 10. Now, two things I can do here. I can go ahead and say, okay, if half of P, so half of 40 would give me 20. And I can just say, I can just do it that way. Or I'm going to show you how you can just write it in. If you don't have that, if you just can't think that, hey, I'm talking about half of the number, so go ahead and do half. So if I do 1/2, just going to plug it in. And I'm going to plug in that 40 right there. Okay. And I know that understood is over 1. So now I can simplify here. I can cross product and simplify. So if I can simplify 2 and 40, 40 will go into, I can. So that would simplify. 40 divided by 2 would give me 20. And 2 divided by 2 would give me 1. So now I have 1 times 20, which is 20 minus 20 equals 10. Is 20 minus 20 equal to 10? No. So this equation is false. Okay. Now, so I know it's not 40, so I'm going to try 60. Okay. So here's what I want you to do. I'm going to go ahead and write this down. I want you to do these last two, and I want you to figure out which one, 60 and that's 80, and I want you to figure out which one of these numbers would give me the correct answer here. Okay, we just did solving two-step equations.